How do? My name is Andrew Hancock and I am a VMware technical architect from Yorkshire in the United Kingdom. I have worked with VMware since their birth in 1998, so that's been a quarter of a century now. I've been working with the VMware product catalogue. Some of my close friends say if you cut Andy in half, it reads VMware like a stick of rock from Blackpool Pleasure Beach. I have now written over 130 articles and recorded over 30 hours of VMware vSphere 7 and 8 videos for Experts Exchange, and received 40 Expert Exchange awards over the last 11 years working with the Expert Exchange community. I am currently the overall #1 point earner in the Hall of Fame. I am honoured to have been accepted into the VMware vExpert program since 2011, and I'm currently a VMware vExpert Pro for the last 4 years. And welcome back to another episode of Hancock's VMware Half Hour. I'm hoping that this isn't going to be 30 minutes, and this is going to be fairly short and fairly compact. And what we're going to discuss today is networking. Now, I know networking is an absolutely massive subject in VMware vSphere. And I'm quite fortunate and lucky that I've worked across many different types of networking equipment, from Cisco, ProCurve, Brocade, Dell, etc., Juniper. And I also have two very good CCIEs that I can fall back on. Thanks, Mike. Thanks, Simon. That I can refer to if I struggle. Now, VMware in VMware vSphere makes it very simple for you to connect your ESXi hosts and vCenter server to a network in whatever infrastructure or whatever vendor kit that you have available. Still got that 100-day cough. And this actually comes up time to time on Experts Exchange in what sort of networking should I use. And recently I've been thinking about this, and I've advised people that it depends really on who's actually providing the network configuration in your environment. Some organizations actually basically have very good network teams and very good network manager that will provide all the networking for you. And all you've got to do basically is just turn on the host and configure the host to match that networking. On the other hand, sometimes it can be the responsibility of the ESXi administrator or the VMware vSphere implementer or designer to actually basically do the networking part as well as the host configuration. And it also basically relies on your own abilities, on how comfortable that you are with networking and where your skill sets lie. So it's a very difficult question sometimes to answer when somebody says, what is the best networking to use for an ESXi host or hosts or vCenter server? Certainly there are best practices, but how you actually implement it and how you configure it, and how much time you actually want to spend configuring the networking to match your ESXi hosts and vCenter server environment. But I must say that your VMware vSphere environment is only as good as your networking infrastructure, including DNS. If you get your networking wrong, you are going to be in a world of pain. One of the other things that I would actually say, definitely for production, doesn't really make a lot of difference in the home lab because we tear them down and we build them up and we use our home labs to learn. But if you're actually implementing a production environment, make sure that you get the networking sorted and resolved and designed and tested. And once you think you've done enough testing, test again. Because when you've gone production in that environment with live workloads, it is very, very difficult to troubleshoot. And it is very difficult to mess around, play with networking, change networking if you've got live workloads. And I know, I've been there, believe you me, it is exciting to get a lot of new tin in boxes Rack them all up in the data center, install ESXi, or sometimes if you've got large enough account with Dell or HPE, they will come ready loaded with ESX. But it's exciting basically to get all that tin racked up in the data center, turn it on, and start putting virtual machines on it. And then we all know virtual machines start in test, and the next moment, management, your organization is putting peer pressure on you to basically get the environment up and running. And the next thing you know, that you're in production and you've not actually basically tested the networking. And little things like 2 switches or 4 switches, and you have a switch failure, or you're just restarting a switch to update it, and you've not actually basically tested the theming and the failover ability, and it all goes terribly wrong. I've been there. So again, just ensure that if you are doing a production environment with VMware vSphere, that you ensure that you have tested your networking to destruction before you go production. Okay, so I've preached long enough on that. Now, anyway, so leading into this, in the last video that I did, which was a monster, it took me over 7 hours to actually basically record that and then edit it all down to 35 minutes for you. But that was all about remediating a vSphere cluster, which is the cluster that we're working on here. And all that was in readiness for our Intel Optane vSAN home lab. Once again, thank you very much, Mr. vSAN. Thank you very much, Matt Mancini, Simon and Matt there, for the demo units from Intel. So I have decided we could build this networking using standard switches. Standard switches where we have to basically create V switches on individual hosts, and we have to go to each individual host to create the configuration there. And I've shown a video and done some articles on what we call VSS or standard switches with VMware vSphere. But I'm going to sort of kind of elevate this one slightly, and we're going to start having a look at VDS or distributed switches. And one of the big benefits of using a distributed switch is that we actually create the configuration. We create the configuration for the VDS, and then we actually add that configuration to hosts as we add hosts into that VDS. So that means that we don't have to go to individual hosts and create a networking configuration. And one of the big benefits, we're only human, it is very easy to make it's very easy to misconfigure one of the switches if we're using VSS. And if you're basically got a cluster and you've misconfigured one of those virtual switches on a host, then again, you're going to be in for a world of pain. And it's easily done. You know, I've seen questions on Experts Exchange where somebody's basically left the VLAN out, or they specified the wrong VLAN, or there's been a typo, or there's been an IP address with a typo in it. If you're using standard switches. With a VDS, we create the distributed environment, and then we actually basically apply that to our hosts. That's one of the benefits. There are many other benefits in the fact that VDS supports LACP, which is a protocol form of trunking, or protocol that exists for trunking on network switches. Now, I was actually in discussion with Mr. vSAN that was talking about LACP in current VMware designs is maybe now being dropped or not looked at. I need to research that further, because I did a quick Google last night and did LACP vSAN, and believe you me, I got lots of hits, and I was reading this and reading that, and I didn't actually basically come across the particular article that he was referring to. But here in the lab, we have a switch that supports LACP. Now, not all switches support LACP. Lots of switches support static trunks. Not all support LACP. A bit like Cisco and the branded Ether channel, they call it, or port channel. So we're going to use LACP. And the reason I'm going to use LACP is a little bit more complicated on the physical switch to configure. Now, here in the lab, I've got many switches, but this particular switch that we're using, and I've just got a serial connection to it, a good old serial connection, because I do actually have a standard serial port still on this particular laptop that I'm using, which it was my daily driver. But to be honest, really, it has a magnesium alloy case. It's built like a brick. It's heavy. I don't use it anymore really for lugging around, but it does have a serial port. So we're actually basically using an IBM Blade rack switch G8124. A lot of these around on that well-known auction site that you can pick up for not a lot of money. I think originally they were Blade, and then I think IBM bought them, and they were IBM, and then I kind of think, oh, the sort of kind of sell off with IBM to Lenovo. They are now under the Lenovo brand. Firmware still available. I think the product itself has been withdrawn. So this is a G1824 10 gig 24 port. I think it's a 24 port gigabit switch. I have already created a configuration on it, but what I'm going to do, I will put that config in the description of this video so that you can actually have a little look at the configuration. And as I was going to say to you before, being familiar with Cisco, Juniper, HPE, Dell, Brocade, etc., I tend to find configuring switches quite exciting, and it's something really that I do actually quite like doing. I hate patching in network cables, even if it's fiber. That is an absolute hate of mine. I haven't got the patience for it. I find it absolutely boring. Give me a serial cable or a Cisco rollover cable and a switch, and I'm like a pig in shit. So I'm just going to show you here a couple of commands. So I'm going to do a show LACP, which is just actually going to show the current LAC parameters for the ports. So I'm using 6 ports on this switch, and I'm using a pair of each ports for each ESXi host. And if I actually basically just look at the info there, then you can actually basically see that I'm using an LACP passive mode. And currently at the moment, all the ports are down, and currently they're all suspended because there is no LACP traffic or LACP commands that are being sent across the wire to bring them up. Okay, so moving on, let's get into our VDS and how do we create our VDS. And creating a VDS for LACP is slightly different than creating a standard VDS environment, because in a standard VDS environment, we would, and you'll see this later, we would add uplinks to the VDS. Whereas when we're using LACP, we add a lag to the VDS. Now, personally, I think that LACP was a little bit of an afterthought, maybe, when VDS was designed, and you'll see why. Because to me, it doesn't look like it's been fully integrated. But as I said, LACP possibly is an old protocol now, no longer supported on a lot of equipment. I have some Dell 4048 ONs here. They don't support LACP anymore, so you do static trunking with them. And I think I have some other equipment as well. HPE equipment, ProCurve equipment, predominantly did an awful lot of LACP in the day. And today maybe I'm actually basically seeing it removed. But for shits and giggles, in this lab, we'll do LACP. We'll see how it works in vSAN. And if it actually basically turns out to be a pile of doo-doo, then we'll go back and we'll change it and we'll convert back to static trunks. Okay, so we're going to go back to just a couple of other things. Currently got SSH connections to all our hosts, 7, 9, and 11, because we're going to be using VMK ping later to test our environment. And what I'm going to do, I'm going to actually basically fail and turn off some of those network interfaces on the switch to check that our environment and our teaming and our failover is all working correctly. Now, LACP, just as a thought, LACP is not supported in ESXi standard switches. LACP is only supported on vDS. There's also another gotcha that you've got to be careful of if you use LACP. And I know that a lot of us do the old shortcut of sbin services h-restart and restart all the network management agents. When we do that, sometimes if we have a problem with ESXi, just got to be a little bit careful in using that, because one of the services is an LAPC service on the host, and you will restart and stop that. And again, you're going to end up in a world of pain. So if you are going to use LACP in production, it's worth actually basically having a look at the pros and cons of using LACP. But again, I think that it's one of those things that's probably disappearing now from our environment. And again, just for shits and giggles, and because it's complicated, some people believe, to get up and running and to get the channels actually basically merging, I thought, I know what, today in this vSAN vDS, let's use LACP. Okay, so I'm going to go to our vCenter 7 single pane of management interface. And you may notice that I've actually got exclamation marks on 7 and 9 because those are currently enabled for SSH. And you can see that I've got that host memory status issue with number 11, which is that memory module, which I need to look at sometime or not worry about. So I'm just going to reset that to green. So the very first thing that I like to do with vDS and really any production environment that I'm planning is I like to create myself a little spreadsheet. So I like to actually basically create a little spreadsheet of the VLAN, the IP addresses, the port groups that we're going to use. Again, I know that a lot of people, it's all very exciting to quickly get this stuff up and all running with no documentation. But certainly if you can actually refer back to, it reminds me of the days really in Novell networking before you actually did any installation. I am going back a few years. Reminds me of the days in Novell networking, you know, when you actually basically installed Novell networking for the first time. You know, there was lots of little books, and then the books, it had notes at the back where you actually basically wrote down all your IP addresses and all your bits and bobs and your server names and things like that. And I still like to do the same sort of kind of thing today. It just makes planning and it just makes the installation and the configuration a little bit easier if you know what VLANs are associated with what port groups, what IP addresses you're using with port groups as well. I've also actually created IP addresses on the switch for these VLANs as well. Now, these are VLANs that I've just plucked out. Yeah, it could be anything. 2030, 2031, 2032. Our management VLAN is going to be 2030. Probably not going to use the management VLAN actually in this lab, but I'm going to create it anyway. vMotion VLAN 2031. Again, we need a storage network for our vSAN traffic, so that's going to be 2032 with IP addresses accordingly. And then these are going to be the names of the port groups that I'm going to create as well. So start with our VDS name is going to be EE-VDS01-vSAN. So this is a VDS that I'm creating specifically for vSAN. Our traffic, our VM traffic at the moment, and our management traffic is still going across standard switches. And maybe in a later video, we'll migrate that all to the VDS as well. I'm just sort of kind of thinking, I think I do have labs getting a little bit complicated, but I think I do have the current lab switch I think connected into the, I'll have to look at that. I'll have to look at that. To move that networking across, I might need to do some networking change. So first things first, and keeping an eye on time here because we're up 18 minutes. So I might be able to speed this up a bit. So distributed switches are included with enterprise licensing. They are also included in vSAN as well. So if you only have standard offering, then you're not going to be able to use vDS. If you've got vSAN, then you're going to get vDS licenses included in vSAN. Enterprise, you've got vDS anyway. So I'm going to click the networking option here. And in our EE training data center, I'm going to right click and I'm going to click distributed switch and I'm going to click new distributed switch. So I'm going to go back to my spreadsheet. I'm going to copy that name just for quickness. And the name of our new distributed switch is going to be called EE-VDS01-vSAN, followed by next. This is a 7.0.3 environment, so I'm just basically going to go with 7.0.3 followed by next. I'm going to create 4 uplinks, but as you'll see, I'm not actually going to use those uplinks because we're using an LACP lag. So normally you would actually make a decision on how many uplinks that you're actually going to use per host, so 2 to 4, but I say for this is just arbitrary really, because it's not really going to be relevant for us in this particular video. I'm not going to create the default port group because I'm going to create our own port groups in a minute now. Followed by next, followed by finish. There we go. Simple, wasn't it? He says. But like the last video that I did that went terribly wrong, anything could happen. So we're now going to get in and I'm going to actually start to create my I'm going to start creating my distributed port groups. So I'm going to go back to my crib sheet. I grab that. I'm going to go with the defaults: static binding, elastic, 8 ports, default. VLAN type is a VLAN. And our VLAN number, I think, was 2030. Just going to go back 2030. Followed by next, followed by finish. And I'm doing exactly the same again. I'm going to do distributed port group, new distributed port group. Now, I'm doing this via the GUI, but all this can be done via PowerShell. Next, VLAN 2031, followed by next, followed by finish. And finally, our vMotion. That's wrong. That should say vSAN. Somebody's been cutting and pasting again. So, distributed port group, new distributed port group. Next, 2032. Followed by next, followed by finish. Now, all we've done there is create a distributed switch. We've named it EE-VDS01-vSAN. We didn't create the default port group, and all we've done there is just create 3 port groups: management, vMotion, and vSAN. And we've made sure that they have the right tag numbers: 2030, 2030, 2030. Can't even remember. 2030, 2031, and 2032. So that's all we've done so far. So this is where things get slightly different when we're doing LACP lag. This is what I sort of kind of think just looks, I don't know, just to me it just looks like an afterthought. I don't know, doesn't flow very well. And I have known a number of people that have actually asked and said, well, I want to create an LACP in vSAN and I can't see where to do it. It's just, I don't know, not an obvious place for me. But anyway, so we select the distributed switch and we click configure. And this actually reminds me to look at the properties here. And we've got an MTU of 1500, which is a standard MTU. So I want to create jumbo frames. So I'm going to change the MTU for 9,000, and I might as well basically put my name and other details in the administrative contact, followed by OK. I don't have to. There's the Lenovo switch, blade switch, IBM switch that I'm using is rather unusual in the fact that I don't have to configure it for jumbo frames. It just does jumbo frames out of the box. Quite a number of switches that I've used, you have to tell the actual port you want to use jumbo frames or 9,000 MTU. But this particular switch, it just does jumbo frames out of the box. There's no need to actually basically specify it in the configuration. So you may see an option there which says the settings LACP. So we click LACP and we now create a new lag. So we click new name. I'll go with the default lag 1. We've got 2 ports. I configured it for passive on the switch already, and timeout mode of long, which is fast, and I'm going to click OK. So that's it. That's our LACP settings that are done in terms of the lag for LACP. I say normally you would actually, when adding the hosts, you would actually basically use an uplink, a network interface. But here we're actually basically just using, we're going to add the lag, and then we're going to apply that lag to both ports. So now the big one is where we're going to add our distributed switch to our hosts. So I'm going to right click the distributed switch, and I'm going to select add and manage hosts. I want to add hosts, so I'm going to select all hosts. Now you can maybe actually start to see the benefit of using a VDS. You know, if we had 50 hosts, 25 hosts, we can add the same networking configuration to all hosts all at the same time. Otherwise, if we were using VSS, we'd have to go around each individual host creating virtual switches and uplinks and VLANs. Yes, it could all be scripted, but certainly in troubleshooting, it makes things a lot more difficult. And of course, with LACP, we've got a lot more functionality in the networking side, IO control. We've got a lot more teaming and failover functionality in the VDS. So if you're licensed for VDS, if VMware is giving away VDS for vSAN, then there's no reason not to use it. Just get your head around it, build a lab, and basically go through and test it out in your lab before taking it to production. So I'm going to select next. So I'm just hoping to move that. So these are all our physical network adapters that we have in each of our hosts. Now, 12 and 13 in both all our hosts are the 10 gigabit network adapters. So I'm going to assign an uplink. Now, normally you would assign uplink 1, uplink 2, uplink 3, uplink 4, etc. But you can see here that I've got this lag. So I'm basically going to select that lag there, lag 10 for VM12. And I'm going to select that lag there. Now, this bit here is the specific bit of LACP. This is what is different if you're doing an LACP. Otherwise, you would just actually basically just select an uplink. So lag 10, lag 11. Now, what I'm hoping here, excuse me. Oh, excuse me. This cough is really getting the better of me. What I'm going to try and do is I'm going to see whether I can minimize all this, because what I want to minimize, what I want to show you is that the moment that, I better log in again. the moment that these ports start talking LACP, hopefully we should actually basically see them come up. It would help if I do enable and conf t first. I have a terrible habit of changing config on switches, but not actually writing it back. If you're a networking person there, you'll know what I mean about startup configurations and running configurations. And sometimes on some switches, you do copy running configuration to startup configuration. We do write mem, but there's no save needed as it's stated there. So just let me put this on pause, and I'm going to come back and resize the screen so that we can actually see this sort of kind of happen in real time. Right, my apologies about that. Didn't think you really wanted to see how somebody actually basically uses a GUI to move things around the screen. Okay, so I just wanted to really show that we can actually see that the moment that we actually basically start talking LACP, hopefully we'll actually start to see the switch recognize and start bringing up them those ports. Otherwise, we've gone wrong somewhere. So I'm just going to click lag 0, lag 1. So I'm going to click next. Okay, so what I'm going to do as well is I'm going to assign port groups now as well to our VM kernel adapters. Now, I've already created these VM kernel adapters on the V switches. So VMK4, I'm going to assign, so I know that VMK4 is our VM kernel management. So I'm going to assign it to our management port group, assign, and VMK5, I'm going to assign to our vMotion, and VMK6, I'm going to assign to our vSAN. So that's all one operation. So what I'm actually doing there, I'm migrating the VM kernel adapters from our standard switches to our VDS at the same time as bringing it all up. So I'm going to click next and next, and I'm going to click finish. Can you actually basically see that all those LACP ports there, port 1, port 2, port 4, port 3, port 2, 6, 1 to 6 have all been brought up. They're all now. So if I go back and have a look at the show LACP, and I show LACP info, now that's interesting because it's actually basically saying that they're currently all down, which I wasn't expecting to see. Interesting. So they were brought up and then they were brought down. And I think I actually know the reason why, and I've sort of kind of slipped up or forgotten. And I'll show you. So again, we're using a lag here. We're not using uplinks. We're using a lag LACP configuration. We're not using uplinks. So if we go to the individual settings of our port groups, and we have just quickly check that we're in VLAN 2030. If I look at our teaming and failover, at the moment the active uplinks are 1, 2, 3, and 4. Well, we don't actually have any active uplink. We don't have uplink 1, 2, or 3, or 4 in our VDS because we're using a lag. So all I need to do is just to move the lag to an active uplink and move all these down. Same with 3. It's a bit painful. somebody watching this is going to turn around and say, "You can do it this way, you idiot." Move down. Not that it actually matters what order they're in if they're unused. 1, 2. It's just me OCD kicking in. Okay, so that looks better in that the active uplink is going to be the lag, and LACP is going to handle the teaming and the failover on that port because it's an LACP trunk. And I'm going to select. We'll leave route based on originating port for the moment. I tend to like to use route based on physical NIC load. So let's select that link status. Okay. And repeat. I was hoping to see whether or not that we'd actually start to see a port go up there now, but nothing's happened at the moment. Anyway, we'll carry on. Edit the settings on here. Teaming and failover, exactly the same. Move that up to active. Move these down. But you've never heard me so quiet, have you? Okay. Lag. Active. Same with vDS. vSAN port. Teaming and failover. Move up. Down. That's one. Okay, so we got there. Yeah, told you LACP is complicated. Yeah, but I didn't think you wanted to really see all that. It's one of the benefits really that I have that I can fall back on, having worked on lots of different networking kit. And if I just sort of kind of go back again to our serial connection into our switch, and I actually have a little look at the LACP info now, you can actually basically see, if you go back in the video and have a little look, you'll spot the error. And I don't know why. I went through this before and it was working. I'll have to go back and check. But anyway, you'll see that the mode is active, and I set the mode to passive, active and passive. And the moment I actually basically set the mode, the right mode to active, then the links actually basically came up. So you can actually basically see that it's selected yes, the trunk's up and the status is up as well. I also went back into our lag here, and I actually specified the mode as active here, timeout fast here as well. So that's it, we're done. Shall I test it? Okay, so at the beginning of this video I kept talking about test, and when you actually think you've done enough testing, then test again. Yeah, I hold my hand up, I've been there, believe you me. And you learn once and you learn the hard way. And even if management's on your back and telling you that they need it tomorrow, then effectively you just turn around and go, well, I've not tested it yet. Do you want to actually basically accept the risk that if we go production on this and it all goes Pete Tong in the future? And to be honest, really, vSAN networking is probably more important than any other networking you're ever going to do. Believe you me, you get your networking wrong with vSAN, you are going to be in a world of shit. Apologies for that, but you really are going to be in a world of shit if you get your networking wrong with vSAN, because it's going to go terribly wrong. Again, you know, vSAN is completely dependent upon good network infrastructure and good configuration and good failover and good teaming and good redundancy. And if you've not got any of that, if your networking disappears or starts having issues, then you're going to start getting replicating issues between nodes. And yeah, you're going to get in a real mess. So if you are going to put together vSAN in production, make sure that you've got adequate time in the plan for testing, or defer to management and turn around and say, your risk if we actually basically go forward with no testing. So enough preaching. I'm going to do some testing. So I'm going to pick a host, any host. Let's pick host number 7. And if I actually refer back to my little diagram, my spreadsheet, so the management interface on, so our IP address, so ping. Now, ping will work, but as I sort of said to you before, the real magical tool to use is VMK ping, because VMK ping can actually send a packet of data through a nominated VM kernel port. So 172.20.30.1 is the IP address of this particular host. So that doesn't really tell us anything other than the fact that the IP address on this host is up. So I'm going to send a packet -I, uppercase I, VMK4 172.20.30.1. So ESXi 9009 is 172.20.30.2. So I'm going to ping that. So that sent a packet through VMK4 and it's pinging ESXi 009. And I'm going to do exactly the same thing with ESXi 11, which is .3. So we've got good communications through VMK4. Just to demonstrate, if I was to send that packet, so if I tried to ping 172.20.30.3 via VMK5, which is the vMotion VLAN 2031, then I would expect that to fail. And exactly the same thing if I send a packet through VMK6 172.20.30.3, then I would expect that to fail. So that simple test really actually shows that we've got good communication from ESXi 00. I'm just a bit, I was just confused then. Let's just do that. So that shows us that we've got communication from ESXi 007 to 009. One of the other things I'm going to do as well is I'm just going to basically ping our VLAN interface on the switch. I can ping the VLAN interface on the switch. And then another important flag is -S 9000. This actually allows us to send a jumbo frame packet across the network. And again, I've seen many installations. I think probably this is probably one of the commonest problems that I see when I go to sites that have networking issues across storage networks, even in a VSS or a VDS, that jumbo frames has been misconfigured somewhere, either on the host or the switch or the SAN, or one particular host has a jumbo frame issue. And of course, if you've got jumbo frame mismatch with vMotion, you're going to get vMotion issues. So if you add, again, same command, vmk ping -I, vmk4 172 -S 9000, that actually sends a jumbo frame packet across the network. So you can see 9008 bytes were sent. If I just drop that, then you can just say 64 bytes. So that definitely proves that between our VMK4 in ESXi 007 to our IP address on our 10 gigabit switch, then we've got jumbo frames operating correctly. So we can apply the same thing now individually to our individual hosts. So between our hosts, again, we've got good jumbo frame connectivity between 7 and 9. And we've got good connectivity between 7 and 11. Now, yeah, it's boring, I know. But the number of spreadsheets that I make up when I'm doing my testing, and I basically just create a little grid. And, you know, realistically, I'll do it here once, but ideally you really actually want to go to the other, like if 7 can ping 9, then 9 should be able to ping 7. So we'll do exactly the same thing. VMK ping -I VMK4. Now, can you sort of kind of start to see the benefit now of using VDS? Because the VDS as was configured, applied exactly the same to all our hosts. So all our hosts should have the same VMKN interfaces. So you can't say that with VSS unless you're very careful that you configure them all in order and you make sure that every vSwitch and every VM kernel is exactly the same. And it makes troubleshooting a lot easier if everything is a standard across your entire environment. So again, VMK ping 172.20.30.1 is the IP address of 007. Okay, I can send 64 bytes between 9 and 7. Again, a jumbo frame, I can send a jumbo frame between the two. So I'm just going to go back to 7, and I'm just going to very quickly test all the other VLANs. So I'm going to do VMK5, and that was 31.2. Okay, we dropped a packet there, and this is sometimes, I've actually seen this sometimes, but it doesn't really alarm me a great deal. I think it's just sometimes the routing tables, spanning tree, I don't know, gremlins. So that's okay. So you can see there was a slight delay there, I think, where it's working stuff out. Yeah. So I'm going to check the final port group, which is our vSAN port group. To wrong IP address then, 32.2. Yeah, that first time out always seems a bit sticky. But I've seen that on every environment that I've done. So I'm not really worried that in this particular home lab thing different. And I'm going to do 3 as well. See that last third ping there just doesn't happen. Okay, so that sort of kind of shows that our LACP lag is up. All our hosts are configured. We've done VMK4, we've done VMK5, we've done VMK6, which is our vSAN network. I thought that was I thought then that something had basically popped on the console from LACP had gone down or something or other. Running changes have not been, yeah, okay. Enable conft. Conft is short for configuration terminal. And let's do a right then, get that config back in there. The reason you actually basically write the running config back to the startup config is if you power off the switch, power the switch back on again, then it's just going to load the existing configuration in the startup. And if you've not written those changes back, then you're going to be running an old configuration. It looks at present like our configuration is all correct. I'm going to do one final check. We're going to actually basically start to fail over networking. And I'm actually going to deliberately start failing ports on our switch. And we'll actually, hopefully we'll see that pings still continue. So we need to do some more testing. We sort of kind of confirmed that we've got good communication across our VLANs between servers. And, you know, in production, really, I would actually go to each individual server and I would actually repeat the test to the rest of the servers in the environment to ensure that they're all communicating with one another. And, we have had a few experts exchange questions on vMotion and storage and said, how can I fix this? Well, there isn't really any magic fix out of the box than getting on the consoles and using VMK ping to actually find out where the communication between the two servers really is failing. And if you look in the logs, if you look in the varlog VM kernel, you will see messages about vMotion failure between a particular host, particular ESXi host. So what we're going to do here, we're going to artificially start failing ports. So I'm going to select port 1. Port 1 is on ESXi 007. So I selected port 1, and if I actually select shutdown, then we can actually basically see that it's telling me the link down on port 1. LACP is down on port 1. What should happen is that we should see a failure eventually, maybe on ESXi 007, that the port is down. But if we actually go to configure and we go to physical adapters and we have a little look at VMNIC 13, then we can actually basically see that that is definitely down. It's possible that the VDS and the lag, I have seen using LACP in an environment, warnings. Certainly the VDS health check seems to struggle because it's the lag and it's LACP that's looking after the load balancing. So if we go to our ESXi 007 and I perform the same operation, so let's just go back to our VMK4. I'm going to ping itself. Forget the IP address, right? 30.1. Okay, so I can ping itself, which I would be expected to do. But now let's just try and ping 2. Then can you actually basically see that even though I've got a failed network interface, VMNIC 13, that I'm still able to ping. I'm going to use -C, which is count 9,000. So it's going to send out 9,000 pings. So if we sort of move that up there, I'm going to go back to our console. It's probably going to be a bit more than 30 minutes, this video. So I'm going to bring that port back up. So I'm going to basically indicate a no shutdown. And if you look, keep an eye on the time to the ping. Sometimes you can actually basically see a slight variation where the teaming is actually basically kicked in and it's changing. I didn't notice anything there. Okay, so our LACP back up, our link is back up. So VMK 13 is back up there. So I'm going to fail the other interface, which is number port 2. And I'm going to do a shutdown on that. And hopefully, okay, so link down on port 2. LACP down is on port 2. You can see that VMK 12 is down. And we can still talk to that server. And I would repeat that on every single server. I'm not going to do it now. I'll do it later just to actually check. But I think you get the idea. Because it would just actually extend this video and it's just repetitive of what I've already done. So there we go. In summary, how we create a VDS for vSAN for our Intel Optane vSAN that's coming soon. How we put together a VDS using LACP brackets. Would I use LACP in production anymore? Probably not. I haven't seen LACP on any vSAN switches in production that I've used for many years. But I was just quite surprised, and this is old kit. I was just quite surprised that this had LACP functionality. So I thought, yeah, okay, let's do some LACP, which is incredibly complicated, he says, in the lab. We've created a VDS. We've added 3 port groups for management, for vSAN, for vMotion. I am going to change the environment here to actually start using our 10 gig networking for vMotion. Don't forget that we would still need to flag those port groups that we've created for those services that we need. And I will do that in the next video. So the next video, we've done our networking piece for vMotion. We've done our networking piece for vSAN network. So the next video I'm going to do is where for the very first time we claim our Intel Optane disks storage, and we'll claim one as a capacity disk. We'll claim one as a caching disk. So we'll have an all flash Intel Optane vSAN data store based on the vDS LACP networking that we've done in this video. Well, I hope you've enjoyed this video. I really have. I really like networking configs. It's one of the things that really gives me a headache when they go wrong. And it's me and the switch and the console cable basically to get them all working. I hate patching servers in, and I hate networking cables. I really do. I have no patience for them at all. And for those guys in the data center that have OCD, that make lovely cable layouts, my respect to you guys, really, or girls, because I think that the work you do there is absolutely incredible. Me, got no patience for it. I really haven't. Anyway, thank you very much for watching this video. I'll bolt all this together. I'll try and speed it up in parts, but I don't really think that there's many areas that we can speed it up. And if you do have any questions about networking, as I say, it's a massive subject. I could probably just do video after video on VMware vSphere networking constantly. But if you do have any networking questions on VMware vSphere, even standard switches or VDS, then ask a question on Experts Exchange. Find me on Twitter, find me on Instagram, find me at Andy's Will. I'm easily found, and just reach out and just ask me a question, and I can discuss at length. You know, sometimes the magic of the forums are great, but sometimes with networking and networking configs, it can be very difficult, because you really have to sort of kind of be hands-on, sort of kind of doing it, looking at the console information available to you. Anyway, so thanks very much for watching this video. Come back soon and have a little look at the Intel Optane vSAN home lab. Okay, thank you very much. Goodbye.